When you put a human being in a spacesuit, suddenly the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For our suit engineers, this means designing, testing, and redesigning to get it right. During Gemini, our designers were faced with a tough challenge to create the very first U.S. spacesuits. Suits that would allow astronauts to work outside the spacecraft in low Earth orbit. Building on that experience, new suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to facilitate tool use and protect the human. During the shuttle years, NASA redefined what could be done with EVA suits and tools, retrieving broken satellites, rescuing and rebuilding the Hubble Space Telescope, and building the International Space Station. The same shuttle spacesuit is on the space station today. It allows us to maintain and repair our home in space. But what about future missions? What kind of a suit will we need? Will we be walking on a planetary surface? Floating in microgravity? Or both? NASA is already investigating the next generation of spacesuits, creating a variety of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We worked with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also help build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started with.
The Z2 isn't just fashion-forward on the outside. It's also technologically advanced on the inside. This is one suit made for walking, on other planets, that is.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that a person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit could be used for EVAs in microgravity, or it could be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, more visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate the changes that need to be made so that it works better the next time.
Whether it's the PXS or the Z2, new NASA spacesuits have a big job to do.
And that's not just being in a vacuum, but it's very hot, it can be very cold. And then in addition to that, there are little micrometeoroids that are flying past that you have to protect in case that does hit the suit. So there's a lot of things that go into protecting the crew member in addition to just being in a vacuum. And when we go farther to the moon or Mars, you have to protect in case you trip and fall. So there's a lot of protection that the suit has to take into account.
No matter where we go or what we do, spacesuits and EVA tasks will continue to change and evolve. To keep up, spacesuit engineers will use new technologies, new materials, and new ideas to help us on our way.
In the future, I'm looking forward to spacesuits that are much more of a tool for the astronaut, that is more integrated with the human, and is less of an encumbrance and more of a help.
I think of EVA as basically a ship of exploration, a ship of learning and understanding, both about what makes us individually human and about what makes us together a team that seeks to learn and understand what the truth around us is. And that search for knowledge, that search for truth is, I think, one of the most noble and meaningful endeavors that we can pursue together.